there are some notable persons. First, Mr. Dey Saab is there, ex immediate past chairman and a well-known academician. And then Mr. Arindam Bose Sahab is there. Sorry, the field of specialization of Dey Sahab is ergonomics, which has got its own name and fame in the mining field also, besides contributing to safety and all these work efficiency. So his specialization is peculiar and well recognized world over. And then Arindam Biswas Sahab is there, a very senior faculty from Nazrul University, Asansol, and specializing in AI and all these digital technologies. And then Mr. Artbosh Sahab is there, Artdas Sahab, who is from Simphar, our member, and they have well prepared for this webinar. And I once again welcome all of you and in this program to make it grand successful. And now I'm switching over to Dey Sahab.
Thank you very much, Tiwari sir, for your commendable words. You have forgot to mention the another panelist, Sri Darshandeep Bhardwaj.
I could not see him here actually.
No, he is
there.
also the panelist number 3.
Yeah.
Where
He's there,
Dr.
yes.
Ankojyoti Das is the moderator. So
Yeah,
panelist 3 is the Darshandeep
Yeah,
Bhardwaj. No problem. I am just adding it up. No problem.
Yeah.
So he is from IBM, a very senior inspectorate there, and working on your digital system on GPS, RS, MSS on this. So he will be you're delivering his thoughts and views as the panelist 3.
Joining later.
Joining later in around say 6 o'clock today.
Yeah.
So now coming back to the today's theme, that it is the smart mining technologies under the you see the man and machine interface, and you see that today's it is the buzzword about the smart mining and with the sustainability everywhere in the globally these words are being taken up. That smart mining, but exactly what do you mean by this smart mining? Do we mean mechanization? Do we mean more production? Do we mean more safety? What is that? Smart mining बोलना बहुत easy चीज है, but that smart mining समझना and that thing to be taken within yourself or one employee's end, it is not that easy thing, because in this digital era, that you see the progress is very high. You see, in all dimensions there is a lot of research and this work of going on, and number of you see the observatory rules and regulations on digitization, mainly on the OSH system, occupational safety and health system, be it of the contractual workers, be of the regular workers of the company based. Everywhere you see this digitization comes into play, and it has come into play more after the Raj Mahal accident. And you see the as per the circular 2/2022, which has come out after the Raj Mahal Court of Inquiry, it has given a wide range of you see the your thrust on the OSH observatory in a digital mode. That is very, very important for all of us to note, that the mechanization itself does not mean everything, because it must have some sort of use on data analytics, some automation, some connectivity to improve the safety standards, some efficiency improvement, some sustainability, which is again another buzzwords of the mining operations in particular. So this sort of you see the smart mining or digitalization we can do through some wireless communication, through AI and ML based and data analytics, data science, all these things with MSS and your TMS or SMP, all these things will give the very valuable insight towards this smart mining technologies to understand. So I believe that today's panelists who are given their chance, panelist 1, 2, and 3, would be doing justice towards this smart mining technology to understand very lucid mannerly, so that all the, because our participants, I believe, mostly the undergraduate level, or maybe some of them in the postgraduate level, but our target should be such that it should be such a lucid level that people get interest, people get involved in it, so that they can understand the total theme very nicely, and so that and not only that, they would be able to utilize it for the cause, for the benefit of the company, for the benefit of the society as a whole. So so I have got all the expectation that today's program will be a really your very good one, and would have a very grand success. Now my job is to introduce the moderator. We have got with us Dr. Orkojyoti Das, who is the senior scientist and head of geomechanics and numerical simulation section of CSIR SIMFAR Dhanbad section. And he has got his name is enough, because he has got a lot of things on his own on behalf of the company SIMFAR, and he is now well known in his field. But still, briefly, I would be introducing Dr. Das in front of everybody. So Dr. Das, Orkojyoti Das, is presently working as a senior scientist and head of geomechanics and numerical simulation section at CSRI, Central Institute of Mining and Fuel Research, Dhanbad. He has received his BE degree in mining engineering from IIST Shibpur and MTech in mine safety engineering from ACSIR, New Delhi, and PhD from IIT ISM, Dhanbad. His research interest is in the field of occupational geomechanics, theoretical and applied rock mechanics, numerical simulation related to coal and metal mining activities. He executed 6 grant-in-aid projects and more than 60 industry-sponsored projects. He has published more than 40 papers in several journals, seminars, symposia, and conferences at national and international repute. He has got 1 book published, 1 patent, and edited 1 proceeding volume of the national conference. He is the recipient of several awards and accolades like INA Young Associate, IEI Young Engineers, MGMI Shivlal Gold Medal, etc., to name a few. So he is with us as the moderator, and we the panelists, the 3, myself, my friend Dr. Arindam Biswas, and another my student come expert and friend is the Darshan Bharadwaj from Nagpur. So now I hand it over to our auditor, our moderator, sorry, Dr. Orkojyoti Das. Dr. Das, please.
Thank you, sir. Your for kind introduction to me, and you are always encouraging to me, sir. So, as a moderator, I would like to welcome everyone in this webinar, which is Smart Mining Technologies under Man and Machine Interface. We are thrilled to have you join us as we dive into a topic that is shaping the future of the mining industry. As we all know, the mining has been a cornerstone of industrial development for the centuries, but in recent years, the integration of advanced technologies has started to redefine what is possible in this field. Automation, artificial intelligence, robotics, and data analytics are not only enhancing the operational efficiency, but are also revolutionizing the safety standards, sustainability efforts, and how we interact with machines in mining. Today's session is designed to explore how these cutting-edge technologies are transforming the traditional man-machine relationship in mining. From autonomous vehicle and remote control equipment to predictive maintenance and AI-powered decision-making, these advancements are creating new opportunities and challenges for mining professionals. We will be hearing from the doyens of academia and experts from IBM, who will walk us through the innovation that are making the mining smarter, safer, and more sustainable. Our distinguished speakers are Professor Nitai Chandra, Head of the Department, Mining Engineering, IIST Shibpur. The second speaker is Dr. Arindam Biswas, Associate Professor, Center of IoT and AI Integration, with education, industry, agriculture. And also, he is the head of the Department of Mining Engineering, School of Mines and Metallurgy, Kazi Nazrul University, Asansol. And Mr. Darshandeep Bharadwaj, Deputy Controller of Mines and Officer in Charge, Indian Bureau of Mines. So our first speaker is Professor N.C. De. As he is well-known figure in the mining fraternity, he doesn't need any introduction. But let me take this privilege to introduce Professor De. It will take me more than 1 hour to speak about Professor De regarding his achievement, awards, and accolades. But let me very brief about him. So Professor Nitai Chandra De is currently Professor HAG and head of the Department Mining Engineering in IIST Shibpur. He is first of 1986 batch of mining and mining of B College under Calcutta University. He holds first class coal mine managership competency certificate since 1990. He has more than 38 years of experience with a unique blend of industry and academia. He has published 4 books and 140 papers and awarded with 11 national level awards. So without further ado, I would like to request Professor De to enrich us by your vast knowledge and experience. Sir, please.
Thank you, Dr. Arkajyoti. Now I am sharing my PPTs with you, and I'll be going a little bit slow primarily so that everybody should understand, because it is the little bit new one, the ergonomics. Okay. Can you see now?
Yeah, it's clear, sir.
Clear. So my topic is smart mining with human factors. That means you see somewhere it is told the human factors, somewhere it is told ergonomics, somewhere it is your physical ergonomics. But whatever thing it is, ultimately the main focus is the man with machine somewhere. But main focus is man. That means the person while working should get comfort, should get, you see, the such sort of, you see, the operational ideas or operational posture, so that he would be getting more comfort, more, you see, the your benefits to run or operate the machine, and its musculoskeletal problems will be very less. Keeping that thing as in the backdrop, we would like to see why ergonomics is important nowadays. So based on that, I will be giving you one very brief your introduction, what I had rather on last September 10. You see, it is not even a month. With the area medical officer of one of the area of Eastern Coalfields Limited, where some point what I have noted down is a remarkable one. Out of 200 patients examined by that concerned Colliery Hospital doctor, 38 number of patients were found suffering from MSD related issues. You see, this is the fact, because I have told you it is one of the area medical officer of ECL. Okay. That and it is not a matter of joke. It is 20% of the patients are suffering from MSD, musculoskeletal disorder related issues, and rest are suffocating from high BP, sugar, liver, lungs related issues. See, even 20% straight are really causing out of the musculoskeletal problem, with knee problem, with waist problem, with some other joint problems, and majority of them now are in the light duty. You understand? While the people are in light duty, your अपना जगह से हट के चले गए, तो automatically उनका efficiency काफी घट गए, क्योंकि उसका designated जो work है, you cannot get it. So while some of them desiring to take early retirement also from the service. So this is the, you see, the information why these ergonomics topics are important to understand, so that if you understand this subject very much, you will be getting rid of this MST related troubles. So now the ergonomic control, you see the block diagram given here, the main machine with health under the given ambience of environment. This is important, that ergonomically how we can control the health of the main and machine both under a given set of environment. Now the focus of ergonomics, as I have already told, is the man. which is, you see, the if we work in a unsafe and unhealthy situations, then we really confronting with, or really will be facing with the different sorts of body posture related troubles, musculoskeletal related troubles, and you see, the while we'll be doing the operation in the sitting posture or standing posture or pulling or pushing under the different environmental factors of noise, because you see the underground में noise hai, vibration is there, illumination is not that much of your acceptable limit, climate is hostile. So out of that, you see that the your comfortness or comfortability of the human beings working there is declining trend. Okay, so our focus is, man, how to increase that in view. So in our overall aim of ergonomics would be to design the technical system or appliances with regard to the anthropometry of the human being, which is very important. Anthropometry of the human being. Anthropometry means the body height and body stature. इसको हम लोग बोलते हैं body anthropometry. So based on that body anthropometry, the human appliances should be built in. Though I've got no doubt to speak, I've got that even today all the equipments are not being built up with the anthropometric goodness or fitness. So it would be, if we can do this, then it will be improving the human safety, human health, comfort, and performance. So the human health means, that means that he will be not suffocating or suffering from that MSD related or your bad posture related troubles. Now the principle of workplace design. We have to have three basic information to be satisfied. One is the anthropometric data, that means the anthropometric information or dimension of the operators, and the nature of job, what type of job it is being working in the underground section or in the open cast or somewhere else, and the behavioral pattern of employees. That is also very important to understand about the ergonomic design of the workplace. And workplace design must satisfy the following criteria. What are the criteria? Out of which the most important, it must be economic. अपने कुछ भी ergonomic principle लगा दो, बस उसमें दाम बढ़ते गए, cost बढ़ते गए, you will not be satisfied to accept it. So that thing to be kept in mind. It must be having the very economical in view, and to enhance the workers' efficiency, to allow the working, to allow good working posture, so that postural related trouble will be minimized, and it will be minimizing the fatigue. That means the delay in onset of fatigue. Your mind the word. Please look at the word, delays the onset of fatigue. That means if the onset of fatigue is delayed, so obviously your working time will be more, and your attention towards the work will be more. So your efficiency obviously will be more, and your accident rate would be less. So that line must be underlined. Delays the onset of fatigue, and it would minimize the health and safety risks such as stresses on the musculoskeletal system. So that it would be saving you the time, it would be saving you your diseases, you will be having the more comfort, so that and thereby having very less amount of stress on your day-to-day work. So there are a few very important terminologies that BMI, body mass index, BSA, body surface area, and LCW is the limit of continuous work. And body mass index is the formula is the weight in kg by height square, which is in meter. And if it is within 25, then it is okay. And BSA is the Dubois equation. You can see this. It is also concerning with the weight and height. And BSA, if it is within 1.9 meters square, if one person has, then his body surface area is very acceptable and very good. You can find it out your own. Okay, because you know your weight, you know your height in centimeter, so you will be finding out BSA. And if your BSA is within 1.9 meters square, then physiologically and ergonomically you are in a very good state. Okay. Now the limit of continuous work, it is what? It is the 35 beats over resting heart rate. 35 beats मतलब BPM, beats per minute. मान लो कि आपका resting heart rate है. Resting means what? Before commencement of any job, the heart rate which is recorded known as the resting heart rate. For example, if your resting heart rate is 70 BPM per minute, okay, beats per minute. So if it arrives at 105, That means 70 plus 35, 105. Then your continuity of work should be stopped. See how much good thing it is. Any layman can understand. Anybody can understand that when your work to be stopped. Even you can understand. You can sitting in your own position, you can find it out. Okay. So anything 35 bits over resting is the limit of continuous work ends. Then you have to have some amount of spell break. That means rest to be taken. अब कितना रेस्ट लेना है मेरा बाद का स्लाइड्स बोलेंगे. Okay. Achha, next. Now, a little bit look about the current statutes, which is given importance on ergonomics in mining. Many people are not aware of it because ergonomics has been included directly in the coal mine regulation and metal mine regulation, which is coming up. CMR 2017 and different circulars are there. Specifically provision 126 and provision 215 of coal mine regulation has clearly stated about the ergonomic design of the operator's cabin. Ergonomic design should be such that they should be stress-free and strain-free. But it has not been detailed because it is not possible. Coal mine regulation never detailed. Okay, it gives you the idea, it gives you the philosophy. Okay, so now it has been cleared little bit in the DGMS circular after 10th conference in safety in New Delhi that the following items should be taken care of. That the assessment of the work process, stress-free working, assessment of the posture, assessment of the tools of different operators, including cabin, and the cardiovascular assessment, which is very important one to understand the stress and strain of the work persons, including operators in mind. Now, again, few important information, because my today's topic is not only limited to mining, you people. It is for all engineering, all people living, even ek ghar ka admi ka bhi hai. Because you see the first point, what is the maximum heart rate when people are required to be hospitalized? You see how much good information it is. Though people should not be hospitalized, I do not pray. But the thing is this, but the knowledge, the information, that what is the maximum heart rate when people must to be hospitalized? It is 220 minus age. You note it down, 220 minus age. Okay. If anybody having 60 years of old, 220 minus 60, so 160 will be the last BPM. So उसका नजदीक किसी का पहुंच रहा तो हॉस्पिटलाइज हो जाना जरूरी है. Because उसका बाद लास्ट 10 बिट काफी तुरंत बढ़ता है. So you cannot resist it. Okay, unless some medical your expertise is imposed on you. Next point is what is the limit of continuous work? I have told you earlier slide. It is 35 beats over the resting. It is the continuous limit. हमारा end हो जाता है. उसका बाद some spell of work, some rest is required, imposed. What is the limit of energy expenditure after which rest is required? It is again of you see the 2.5 kilocalorie. 2.5 किलोकैलोरी पर मिनट से ऊपर किसी का ये जा रहा होगा वो कोई वर्किंग का, सो आपको थोड़ा बहुत रेस्ट होना चाहिए. नाउ you can see the table here. The table gives you some idea about the classification of workload. It has got the 5 different types of classification. You see here there is a light type, moderate type, heavy type, very heavy type, and extremely heavy type. You see, these are the different, you see the classification of workload. But I am really sorry to say that in India, besides me, none have worked on this. None. मेरा कौन सा ऑपरेशन कौन सा वर्कलोड का है किसी को पता नहीं है. किसी को पता नहीं है. फॉर एग्जांपल रूप बोल्टिंग ऑपरेशन कौन सा वर्कलोड का है. एसडीएल ऑपरेटर कौन सा का है. कंटीन्यूअस माइनर कौन सा है. किसी को पता नहीं है. ठीक है ना. सो दिस थिंग हमारा क्या ऑल डेवलप्ड कंट्री दे हैव मेड इट बट वी डोंट हैव. सो नाउ दिस कॉन्सेप्ट आई एम ट्राइंग टू built in so that our younger generations, for what this your webinar is made for, कि हमारा younger generation थोड़ा सा सामने आएंगे, थोड़ा सा इसको और सीखेंगे, थोड़ा सा और implement करेंगे, then only it is important. And you see the parameter used here is the 3 different parameters. Working heart rate, WHR means working heart rate, then energy expenditure, then net cardiac cost. NCC means net cardiac cost. It is one of the very important stress parameter. Physiological. And so the three different scientists has given the reference as Strand, Ramanathan, and Camox. Okay, and based on that, the classification of workload has been made. And you see, हम एक तो थोड़ा सा एग्जांपल दिखाया SDL ऑपरेटर का, दो माइन का, माइन ए एंड माइन बी, छह ऑपरेटर का हम लोग करके ये एवरेज दिया. So देने के बाद you can see that the mine A working heart rate of the operator 133.5 and mine B 116.9, energy expenditure आ रहा 5.7 and 5, and NCC net cardiac cost आ रहा है 48 and 40. So remarks column में हमने दिया है क्या कि very heavy in nature and mine B का है heavy in nature and energy expenditure देखते हुए both are heavy in nature and here NCC देखते हुए भी both are heavy in nature. But here one problem I can notice here that age is not considered. So the lacuna of this classification is age is not considered, because you will be agreeing with me that age should be considered because age has got tremendous importance. 155 years old, 125 years old is not same. Is not same, never. So the same workload for two people, two different person of 55 years age and 25 years age, you mean a lot, So now next your PPT, this cardiac strain index proposal has been coined by me only, myself along with my PhD scholars. All of them has got their PhD awarded under me. You can see the NC Day, S. Nath, GD Sharma, and SC Day. And we have coined this new terminology, the cardiac stress index. Here what we have done. Here we have you see that inculcated the age. What we have done that the first we have done the maximum heart rate. You see this one. What I am this thing highlighting. 220 minus age is 25. You see, age is 25. So 220 minus 25. His age is now the HR max is 195. So and if the average working heart rate is 130 beats per minute. So how much is the percentage of this working heart rate of 130? How much percentage of maximum heart rate? That is the cardiac stress index. So in this example, it is 66%. You see, because 130 coming out of 195, you can see the 66%. So if it is 66%, so work will be heavy, not the very heavy, because you see if the earlier slide you see 130 means the very heavy. You see that it has got the very heavy, but it is not like this under that it would be under heavy or in the you see the moderate categories. So if it is accepted, we will be applying to ACGH, American Conference of Governmental Institute of Hygiene. If we are applying this thing, if they permit this, then the cardiac stress index, this would be which has been proposed by us, can be added together. And now you see the just for example, I have shown you the two different heart rate profile of the SDL operators of different mine A and mine B. You can see that this total right from resting, reaching, then working, pre-working, then working, then the heart rate while reaching at the peak, it is there, and recovery means after cessation of the job. बंद हो गया, आप अब रेस्ट करोगे 5 मिनट 2 मिनट, मतलब स्पेल चेंज, स्पेल 1 to spell 2, spell 2 to spell 3. So this is the recovery time. Okay, so see, you can see that SDL operator mine A, SDL operator mine B, दोनों का हमने दिखाया कि पीक देखिए कितना ऊंचा पहुंच गया, 158 and 138. दैट मीन्स क्या माइन बी का एनवायरमेंट जरूर अच्छा होगा. So इसीलिए माइन बी का क्या बोलते हैं मैक्स पीक इज 138 and it is the machine through which we do it. It is the mobile heart rate monitor. अपने यहाँ जो देख रहे हो ये MHRM का है, ये it looks like ECG. ओके, देखिए आपका हाईएस्ट बीट देखिए कहाँ पहुंच रहा है, यहाँ पे ठीक है, it is touching towards the red. It is the highest peak. Okay, so this your curve we are getting out of the MHRM mobile heart rate monitor. वहां से हमने इसको दिखाया, फैक्ट है एकदम ओरिजिनल. You see now the आगे वाला दिखाया था वर्किंग हार्ट रेट का, ये दिखा रहे हैं आपको एनर्जी एक्सपेंडिचर का. तो एनर्जी एक्सपेंडिचर ऑफ द सिमिलर टू एसडीएल ऑपरेटर फ्रॉम रेस्टिंग, रीचिंग, प्री वर्किंग, वर्किंग, फिर पीक में पहुंच गए, फिर रिकवरी में, दोनों का दिखा है. व्हाई दिस आर द ग्रीन? बिकॉज यू सी द 2.5 और विद इन 3, सो दैट्स व्हाई दिस इज गुड. सो ग्रीन में दिखा है. देखो जहां पर हमारा वो लाल हो गया, रेड किए, मतलब इट इज मोर देन 3, सो व्हिच इज नॉट एक्सेप्टेबल. तो इसमें आइदर उसका फिजियोलॉजिकल प्रॉब्लम है, और वहां पे he has got the little bit of trouble with the environment may be more hostile, or in velocity of the air, or cooling temperature or coolness should be added together, or looked at, or ventilation survey should be done there, and the continuity of work may be high, continuity of work may be stalled, may be broken into some rest, then again we can start the spell 2. सो एंड एनर्जी एक्सपेंडिचर प्रोफाइल का साथ हम सेडेंटरी पर्सन का साथ एक तो कंपेयर किया. देखिए नीचे वाला है सेडेंटरी पर्सन, व्हाइल ही इज रेस्टिंग, और घर में काम कर रहे हैं, छोटा मोटा बैठे हैं. देखिए उनका क्या होता है, देखिए उनका हार्ट रेट प्रोफाइल कैसा जाता है, एनर्जी एक्सपेंडिचर कैसा जाता है. और देखिए जो काम कर रहे हैं उनका क्या जाता है. ठीक है भाई, इट इज फैक्ट कितना दूर तक जा रहा है. ठीक है ना. देखिए सेडेंटरी का साथ काम का कितना डिफरेंस है. बट दैट डिफरेंस यू हैव टू अंडरस्टैंड, दैट इज इंपॉर्टेंट. How much is the acceptable, how much is the you can allow, where you have to put break, where you have to put the rest pause, that is important. Okay, work pause for the rest. So that's why this is very handy comparison. And these are the instrument we have used: anthropometric kit for having the weight, for having your height, and sphygmomanometer for your BP, then weighing machine for your weight, ECG machine for your heart positions or working positions, Aspen hygrometer for humidity, Kata thermometer for coolingness, anemometer for velocity, mobile heart rate monitor. This is very important one, very handy for this job. This is, you see, this is the sensor and this is the clock. This is the clock, and we have to put it over our chest, and the clock, your जो clock है वो हम लोग का wrist band पे रहेगा. So it will be giving you continuously the heart rate during work. If we set it every 10 seconds, it will give every 10 seconds. If we set it every 5 minutes, it will get at every 5 minutes. And all the data is stored in the watch, and it is downloadable by the PC. It is very important and very useful and handy thing. हमने देखिए माइंड में हम लोग कराए थे ड्रिलर को, इसका पिक्चर हमने दिखाया है. Now the VO2 analyzer, treadmill, oxylog, all these are the very important items for this, for the different experiment, not used here, but for the ergonomist or those who are giving or creating, you're having lot of interest out of it, they would be acclimatizing on that. And now the little bit of छोटा mathematics देखिए किस तरह से stress निकाला जाता है calculation करके. For example, this is the heart rate आपको मिला है by the MHRM. Okay, resting heart rate आपका 78 था, आपका एज है 58. ओके, सो नाउ द फाइंडिंग आउट द योर स्ट्रेस इज एनसीसी, स्ट्रेस इज आरसीसी. ये दोनों हमारा स्ट्रेस पैरामीटर है, नेट कार्डियक कॉस्ट एंड रिलेटिव कार्डियक कॉस्ट. ओके, बोथ, and both should be below 30% if we call that the guys are not having the stress. Okay, so this NCC, how will be calculating the working heart rate average minus HR rest. HR rest we are having from here 78, and working heart rate average you have to find out from here. What we have got 109.2. So 109.2 minus 78, 31.2 is the NCC. And now we will be finding the RCC. RCC में देखिए क्या है, NCC divided by HRR. HRR is heart rate reserve. Heart rate reserve. What is heart rate reserve? Heart rate reserve is nothing but HR max minus HR rest. HR max is what? 220 minus H is the heart rate max. Minus HR rest is what? Is the 78. इसको करके हमको मिला 84. तो हमने क्या किया, 31.2 divided by 84, 37.2% हमारा आया. So this is more than the proposed by the Lavlange and Combeer. Lavlange, Combeer and Lay, ये लोग propose किया कि हमारा stress limit 30% तक होना चाहिए. But this particular gentleman is 37%. So he has to take break, he has to take rest, or our working condition or the environment, we have to again rebuild or relook. Likewise, the RAS, relative aerobic strain, we have to find out that VO2 at work, VO2 at max. This is the formula. Based on that, we are finding RAS on this. you will be astonished to note that this percentage we are comparing with the US norms. We don't have even in India. We don't have even any this sort of you see the parametric reference from our country. Nobody has done. Whatever I am giving, I am showing. It is only my work in India. तिवारी साहब थोड़ा देर पहले बोल रहा था कि ergonomics का काम NC ने ही किया. So I have done that. Whatever I have done that, I am showing you. Okay? और ये कुछ बनावट नहीं है. Whatever I am done in the underground with the people in front physically, I am showing you. And that is 53%. But comparing with the US norms, it is not correct. But what can we do? What can we do? We don't have any reference point. I am trying to make it as reference point. Okay, it will take a little bit of months and time, but afterwards I will be giving it. And see the different ergonomic scientist Spitzer model is very important. हमको आप थोड़ा fast करना पड़ेगा. और को जो थी, how much time I have? Don't have ना? Is it 20 minutes over? और को? अच्छा, Spitzer model. Spitzer model, what calories by 4 minus 1 into 100. This will give you the how much rest you have to take within 1 hour. Okay, I am just keeping it. And fatigue. Fatigue is very important because but we have to delay the onset of fatigue and we have to have the faster recovery. This is important. Faster recovery indicates what? Adequate capacity to perform a job. So if we cannot do the adequate capacity or faster recovery, then we will be saying that our fatigue will be onset. We cannot delay them. Nah. So which is our objective? Our objective is what? Delay the onset of fatigue. So, but so it will be possible if it is the faster recovery. Then again your rest time will be less. If the rest time will be less, so obviously work time will be more. If the work time will be more, so obviously the production and productivity will be more. So according to Bravois, he has given some sort of your indication how to estimate or assess the fatigue. You see that the normal P1 and P2 and P3, these are the 3 different pulse rate indicator which is recorded just after cessation of the work. Cessation of the work. Cessation मतलब just हमने काम बंद किया, उसके बाद within first 3 minutes. फर्स्ट मिनट में हम लोग जो लिए फर्स्ट रेट पल्स रेट उसको हम लोग बोलेंगे P1. सेकंड मिनट में हम लोग जो लिया उसको हम लोग बोलेंगे P2. थर्ड मिनट में हम लोग जो लिए उसको बोलेंगे हम लोग P3. सो वो P1 P2 P3 लेके हमको ये टेबल पे जाना है, जाके इसको हमको कंपेयर करना है. एंड इफ वी फाइंड देन वी हैव टू फाइंड इट वेदर यू आर नॉर्मल, वेदर यू आर रिकवरी, वेदर यू आर इनवर्स रिकवरी, व्हाट. बेस्ड ऑन दैट योर फर्दर वर्क विल बी डिजाइन. ओके. और को যদি আর কতক্ষণ can I go little bit? 5 minutes?
Yes, sir. 5 minutes, sir. Please.
5 minutes. Okay. So determination of work rest scheduling for mine workers under given set of your environmental condition. I'll be a little fast, but it is very, very important. You see the environmental parameters of mine. All this data are really authenticated. Okay. You look at this 2 column. Or WBGT value, weight bulb globe temperature and effective temperature. You see, these are the environmental parameters, stress parameter. You see 24 and 23.9. Okay. And you see a lot of other parameters, dry bulb, wet bulb, globe bulb, natural well bulb, air velocity, relative humidity, all are there. But you look at this too. It has got some reason. Okay. Next also, here पर भी mine B का है. See, here पर भी you look at on this too. ठीक है, 29.82 and 30.6. Fine. And you see that stretch of roof bolters, हम लोग दिखाया कि what type of you see the through pie chart, what is the percentage of different sorts of time consuming during his work. And now you see the stretch of time in this diagram I am showing you. The work duration कितना है? 126 minutes. How much spell he has done? 4. How much your spell per shift? एक spell का you divide 126 divided by 4, you will be finding 31.68. So this is the total job element. You know, working with machine, attaching the beads with the rod, drilling in the roof, soaking with the cement cartridge, pushing the cement cartridge, insertion of the bolts, attaching the plate, tightening of the plate, everything given, you see. And altogether it is coming up. You see the total time what is coming up, it is divided with this 7 effective hours per the shift. Okay. So now I am just hurriedly. It is for underground trauma. Same thing I have done. Okay, I am not going that. Now you see that for the observed ET value 30.6 and 23.94. देखो एक बार हम फिर आगे जाते हैं 30.6 23.94 ना थोड़ा सा उधर आगे जाकर देख लेते हैं 30.6 এদিকে 30.6 এদিকে 23.94 you can see this thing has been taken এদিকে 30.6 this thing has been taken. Okay, so again I am going back there. See, and see, this is the permissible World Health Organization given for different type of job: light job, moderate job, heavy. Heavy includes all: heavy, very heavy, unduly heavy, everything under heavy. Okay, then ET for non-acclimatized person, ET for acclimatized person. कितना होना चाहिए दिया? देखो हमारा रूप बोल्टर का ET कितना है 30.6. So 30.6 इसका मतलब क्या? For the heavy job, it should have been for acclimatized job 28.5, but इतना है 30.6 है, so it is much above. So लिखा हुआ है above the limit, you see. And 23.94 है क्या? ट्रामर का हमारा क्या है? Moderate job होना चाहिए था 30, high 23.9, so it is within the limit. Okay, so within the limit में हमारा, और देखिए हमारा हीट जोन टेम्परेचर जोन में क्या है? इसमें देखिए मोर देन 30.6, इसका मतलब माइन बी इज अंडर वेरी हॉट जोन, माइन ए इज अंडर कंफर्टेबल जोन बेस्ड ऑन द एनवायरमेंटल जोन गिवन बाय द बेस्ड ऑन द ईटी. ठीक है ना? आप देखिए बस स्लाइड हम खत्म कर रहे हैं. आप देखिए इसमें लास्ट वन, हाउ इट इज बिंग योर हाउ मच रेस्ट, हाउ मच वर्क दे सी. सो इफ इट इज द हेवी जॉब and rope bolters is the 29 point. This is the WBGT value. Okay, WBGT value एक बार मैं फिर देखा कि 29.82 and 24.14. एक बार मैं फिर उधर जाते हैं 29.82. See 29.82 I have got. See 29.82. Okay, and you see the आगे वाला हमारा था 24.14. Fine. ये देखिए फिर यहाँ पर हमने आ गए 29.82 24.14. सो 29.82 इसमें हमारा क्या आ रहा है? ये 50% वर्क 50% रेस्ट. और 24.14 में क्या आ रहा है? कॉन्टिन्यूअस वर्क, बिकॉज इट इज कमिंग अंडर हियर. ओके, सो एक्चुअली हमारा क्या है? द रूप बोल्टर इज वर्किंग एक्चुअल वर्क 18.1 मिनट पर आवर, बट उनका होना चाहिए 30 मिनट. ये कम कर रहे हैं. ही इज वर्किंग लेस for the cause of the company, while you see the underground tremor 41.5 minutes actually कम कर रहा, but उनको continuously होना चाहिए for that particular mine. Mind that for that particular mine, if the mine condition changes, if the environmental changes, it may also change. So our the management का क्या responsibility है? To give the very not the hostile environment, very comfortable environment to work. So now the conclusion: workstation design should be such that ergonomic considerations should be in view for the benefit of the your operators, and the review of the ergonomic based designing should be done, specifically the cabin and other seat through the CMR and other directives, and determination of workload and adequate work regimen should be find it out for all unit operation. Attempts should be made to delay the onset of fatigue. Our target should be that, and postural study of all sorts of operators should be there to understand the comfort level or the long stretch level or whatever they are consuming or not, assuming or not, so that the proper work rate scheduling can be made. So with this, I am coming to the end of my talk and speech. If you have got any confusion or any question, I will be dealing with after our two panelists speech. Thank you very much.
Thank you, sir, for enlightening us how the importance of the ergonomics is. And I understand that it is very difficult to sum up your 30 years of work within this short period. So actually, we need the one-day session to understand the whole ergonomics.
Yeah.
Yeah. So our next distinguished speaker, next distinguished speaker is Dr. Arindam Biswas. So he is Associate Professor, Center for IoT and AI Integration with Education Industry Agriculture, and HOD of Department of Mining Engineering, School of Mines and Metallurgy, Kazi Nazrul University, Asansol. So let me brief about his biodata. Professor Biswas received the MTech degree in Radio Physics and Electronics from University of Calcutta, India in 2010 and PhD from NIT Durgapur in 2013. He has worked as a postdoctoral researcher at Pusan National University, South Korea with prestigious BK21 Plus Fellowship, Republic of Korea. Dr. Biswas has received GST JSPS Invitation Fellow at REI Japan, DST Asian Invitation Fellow at Dutan University, Vietnam, and many more. He has worked as specially appointed associate professor, visiting professor at Research Institute of Electronics, Shizuoka University, Japan. He has been selected for Institute of Engineers Young Researcher Award, Kazi Nazrul University Best Researcher Award, and he has in credit of several awards and accolades. Dr. Biswas is working as a he has 75 technical papers in different journals and 47 conference proceedings and 8 authored books and monograms, 25 edited volume and 10 book chapter with international repute. Dr. Biswas received research grants from different funding agencies, namely ACRB, DST Asian, DST JSPS, Center of Biomedical Engineering, Tokyo Medical and Dental University in association with RIEC, Shizuoka University, Japan, for 4 consecutive years. He is serving as adjunct professor, Taylor's University, Malaysia, since February 2024. Dr. Biswas has produced 8 PhD students till date, and 1 has submitted their thesis for PhD. He has organized and chaired different international conferences in India and abroad. He is life member of the Institute of Engineers, MGMI, and regular fellow of Optical Society of India, member of IEEE. With his vast research experience, we are eagerly waiting for hearing from you, sir. So, without wasting the time, the audience and the attendees are wanted to listen you, sir. So, sir, please.
May I audible?
Yeah.
Dr. Das?
Audible.
Yes. Yeah.
Thank you, Dr. Das, for your nice introduction. So today I am today I am presenting the digital mining towards industry 4.0, mine safety and productivity. Actually, I am basically from the electronics background. I am presently working as an associate professor in head department of mining engineering. I am trying to introduce some concept of IoT and AI, how digital mining, how IoT and AI can change the mining industry. I am working on that. So in today's presentation, I will present some of my work and as well as what are going in our university at Kazi Nazrul University, and this is active guidance of obviously Professor Nitai Chandra De. He's over here. Since the department is done, we are guided by Professor De, and I am thankful to Professor De for this nice opportunity. So today I am presenting the digital mining towards the industry 4.0. One quote from the chief operating officers from to Canadian mining company.
Arindam, one thing, I'm just sorry to stop you. You see the Orco,
Yes,
some
sir.
guys are, some participants are writing ki they are unable to see. So whether Arindam can ask that the people can see his presentation now?
I think you are seeing, sir, my presentation.
I can see, but what about the participants? Why they are writing?
This participant,
one participant, can one participant speak? Is it visible?
I think that's written from your presentation part. They are DM Rao asking for sliding mode only.
Oh,
Slide mode only, sir. Yeah.
Slide mode only.
So it is good. Sorry to interrupt. Sorry to interrupt, Arindam.
No. Thank you, sir.
Please carry it.
Yes. And I have taken a quote from 2 Canadian chief operating officers from 2 Canadian companies that if we don't change the business of mining, we won't have a mining business. So we have to change the mining industry. We have to looking forward to the digital mining technologies. Now, what is Industry 4.0? The fourth industrial revolution we have seen. The Industry 1.0, that will be the mechanization and the introduction of steam and water power. Then we introduce the Industry 2.0. That's what the mass production assembly lines using the electrical power. Then Industry 3.0, that automated production introduced computer, IT systems and robotics, and now are working on Industry 4.0. Now we are working on the digital transformation of the hardcore industry. We are looking for the smart factory. We are looking for the autonomous system using IoT, machine learning, robotics. So this is the era of Industry 4.0, or even this is the era of Industry 4.0. We are working on it. So what is IoT? IoT nothing but the Internet of Things network of physical and Internet of Things are the physical and Internet of Things are is the network physical object. Object means themes embedded with the electronic software, sensor and network connectivity, which enables this object to collect the and exchange the data. Means we have to this is technology, internet technology. You have to send some data. Then you have to communicate the data to the user, subscriber or user. This is the Internet of Things, and it allows the and to be sense the control remotely access existing network infrastructure, creating the opportunities of more direct integration between the physical world and the computer-based world, and resulting the improved efficiency, accuracy, and the economic benefit. Those are the important things of the IoT. Now, IoT ecosystem. We think this is a sensor. This sensor sense the data through the smart things and wearable things. Then immediately communication and processing devices are there that process the data. Then the data should be communicated to the cloud, and after that cloud, the real-time processing, the visualization, presenting of recommendation of data is required, and there is a data archive, and this cloud is directly communicated with the data archive, and ultimately it will be communicated to the end users. And the ecosystem components, this is the IoT, some manufacturing devices are there, the sensor and actuator there, smart appliances and network service provider are there, and some operating cloud service provider are there, and the platform devices, middleware provider, SRT, and third-party application developers. Those are developers tools and APIs, and those some based on the some IoT and apps. The integrated ecosystems will be introduced. And how IoT works? At first, this is the RFID, then sensor, then smart text and nanotech. What are RFID is used to identify, track the data of things. Then sensor, that sensor collect and process the data to detect the change in physical status of the things. Then smart tech to ensure the power of the network by developing processing capabilities to be part of this network, and ultimately to make the smaller and smaller things to have the ability to connect and interact. And this is the 4 steps to show the working principles of the IoT. Now, the global market for Industry 4.0. Industry 4.0 basically the digital transformation of the industry. That digital transformations happens through Internet of Things, machine learning, deep learning as well. So Internet of Things basically based on the sensors and RFID, and how much devices now connected with a man. And this is the related to Internet of Things. If you see previously one man is associated with laptop. Now one man is associated with a laptop, one computer, one laptop, one smartphone, and smartphone with various devices, one smart watch. So this is the billions number of devices connected to the society, man, and the number of year. So that is exponential. We think the number Internet of Things and the expansion of connectivity possibilities is exponentially increased. Now, what do you need this? This is the present scenario, present scenario, and this is the control office. From this control office, we control the in the hardware industry, but we need to think into this, that we can control with a smartphone only and with a smartwatch only. We are working on the IoT technology. We are working on this principle. Now, based on these motivations, we have established the Center for IoT and AI Integration with Education, Industry, Agriculture at Kazi Nazrul University. We are working on digital transformation of a mining industry or digital transformation of any hardware industry. That is the industry. We are working on the industry 4.0. We are working on the education 4.0. We are working on the agriculture 4.0. And digital evolution of the agriculture is so important for the society. So our Center for IoT and AI is working for the digital transformations of agriculture, industry, and education. And we are trying to develop the new mines, sustainable existing mines, and improve the environmental performance. The research, development, implementation, and commercialization. Those are the four basic things of the any revolution. Like industry 4.0, there is a college, university and colleges, small business innovators are there. They are working together and there is a demonstration and implementation part and they're hand-to-hand working together to supply the solution to the industry producer. There is the innovation gap and there is the commercialization gap. So if this research, development, implementation, and commercialization work together, that will be the possible way to implement and implement any technologies from university to industry. Now, on this theme, we have acquired a project from DST, that environmental monitoring and underground mines with sensor-enabled Internet of Things. So we have with this project we have able to there are several objectives, but we are able to develop a prototype for methane gas sensing using IoT for underground mines. So those approved objective was development and environmental monitoring system for underground mines, which can be effectively measured to a real status of hazardous gas emission, temperature, humidity, air pressure, and dust generations. Development of a miners equipment tracking system, which keeps record the respective locations of miner and equipment in order to facilitate the miners in practice surrounding status, as well as the emergency system. And also we are looking for the development of an alarming system. That alarming system will alarm if any case of emergency or unsafe conditions in the mines, and development in underground mines, and also development the guiding system, recovery system and guiding system, how the miners can leave to the safe place in case of any mishap. So this is the fire dam graph where this is taken from the this chart is taken from the DGMS data from 2002. Due to the fire dam explosion, how many accidents in underground mines, and here is some. This is a Nadir Ghost Colliery in 1998 to 2026. Data is there. Data is here that there is several accidents due to the fire dam explosion. If we able to introduce a good alarming systems for this for methane gas emissions, so that then the systems can be improved and no further accidents in underground mines due to gas emissions can be prevented. And we know the mixture consisted of severely methane gas, which is a combination of ethane and ethylene. So we have to work for it. Now this is the methane gas explosion diagram. We there is a several methane gas explosion diagram. You know, this is the ABC diagram, that when the methane and oxygen combines in a specific concentration, they form potentially flammable or explosive mixture. The methane will burn smoothly when its concentration is below 5, below 5. From this graph, it is clear. And when it contact with the thermal source, however, when the concentration ranges between the 5 to 15%, methane and air will create the explosive mixture. And the most explosions occurs when the methane is present at a 9% concentration with the oxygen content exceeding 12%. The particular concentration is referred to as stoichiometric concentration, and beyond this methane gas concentration of 50%, the methane becomes flammable, and it roads nothing for any of this scenario occur, and energy this explosion conditions are illustrated in crowd methane explosion triangle, and that is important, and this ABC triangle serves as the critical maker defining the concentration range where methane can be explosive mixture. Now we have developed a resistive type methane gas concentration transmitting using the SNO2 materials. In the present case, a SNO2 layer is the sensing medium which decrease SNO2 materials. SNO2 is the sensing materials that decreases the thermal resistance with that increase the methane concentration, and a Wheatstone bridge detect the decrease of resistance, thereby converting to the suitable voltage. So this sensing unit is developed by our group at Kazi Nazrul University. This SNO2 based sensor, actually in case of any gas sensor, we know the gas sensor, any gas sensor is the multi-gas sensor. So we have to work on the sensitivity of a gas sensor. But particularly if sensitivity is high for any particular gas, so that sensor will be treated as that gas sensor. So we have developed a SNO2 based layer sensing medium for methane gas that decreases the electrical resistance with the increase of methane concentration. If that electrical resistance increases, that in case that there was a Wheatstone bridge that detect the decrease in resistance and thereby converting into the suitable voltage. We have visited several mines for this study of the sensing materials. Then we have this is our methane gas concentration measurement unit. This is the sensing unit. Then Wheatstone bridge unit, then analog amplifier, then signal controlling unit, then microcontroller unit, then publisher, and publisher to cloud, and ultimately it through IoT it sent to the subscriber. And this is our sensing unit we have developed. Here the SNO2 is selected as the functional material for the sensor due to the host of the advantage of the attribution it processes, emphasizing its cost effective emphasizes for its cost effective, highly sensitivity, impressive thermodynamic stability, and notably capability to absorb the dissolved gaseous molecules, considering the highlighted temperature augment for responsibilities a broad spectrum gases. And a heater is there, have been incorporated in the sensor. Additionally, a fan has been is introduced for a concentrated airflow between the inlet and outlet, and the safety and additional safety measures is anticipated, and in any potential risks arising from the high temperature, then that also this fan also used for cooling purpose also. And under this normal condition with air clean, sensor resistance remains resistively slow. However, in presence methane in the air, it absorbs onto the sensor surface and leading to the reduction of SNO2 materials resistance, and consequently the concentration of methane in air determined by tracking of the sensor resistance alternative, and a comprehensive and this is the comprehensive overview of this sensing unit. Now from sensing unit, we have developed that at IoT based systems, and where the hardware platform ESP32 based node MCU is utilized for the study. Sensor configuration we have already told, and data collection and storage for Amazon AWS cloud services are employed for collection the data, storage and analysis of the gathered data, and IoT cloud platform, Canoi IoT platform use. This is the user friendly. This is the free for academic purpose and forecasting model. We have used one forecasting model, LSTM.
Dr. Vishal, sorry to interrupt you.
Yes,
Please try to conclude within 3 minutes.
Okay. So this is the another. This is the machine learning based forecasting model, LSTM model we have used, and that model is hosted in the Amazon cloud services, implemented for predicting the methane values. And the forecasting model predict values 8 hours ahead and aiding the in predictive. And this is the our visualization network framing network. You so that you can show that network. This network, this is the network, and this network is for internet. This I already told. This is the CANI IoT services, then mobile apps, and this is that sensor unit is here. IoT enabled devices. The router is there, and what happened? Router is there, and this is the schematic diagram of the IoT devices, and this is the prototype model we have developed using the sensing unit. And here the methane gas sensor is there. Temperature, we have also taken input as a humidity and temperature and humidity sensors, and we have already told that we have used the ESP32, and this is the buzzer. We have the alarming systems, and this is display. This is our schematic model. And this is a schematic representation of the controlling unit. There, Wheatstone bridge is there. We have already told if the methane gas is increased, then resistance decreases. That decrease of resistance is captured by this Wheatstone bridge, and after that, that will be converted to the corresponding voltages for giving the outputs. And this is our calibration unit in our laboratory, and we have used this gas testing chambers and methane gas for this study. And this is the calibration curve for the methane sensors and methane concentration in ppm and with the output voltage, and that means planning high locations where a device may be installed. And we have already told that we have used the LSTM based machine learning model that is deployed in the Amazon Web Service Web Clouds. And here we have taken the data in continuously 8 hours. Data can be captured, and based on the data, they are giving the predictive model. And these the various notions deployed in the illustrate the models, and that. Then this is the flowchart. This is the flowchart that start initialize the system, sensor data received by the IoT devices, and then data sent to the AWS cloud and KINI cloud through the using MQTT protocol. Then methane gas concentration, then continuous buzzers. Then it is ultimately come to the buzzer beeping systems and ultimately in stop. And another is the forecasting through by LSTM model, and that LSTM forecasting model is the data sent to the CANI cloud, and the real-time forecast methane gas concentration of the minor CANI cloud mobile application dashboard, and ultimately it is finalized. And this is the snapshot of actual and forecast.
Please,
okay.
Sum it up quickly, please.
We have compared with the different location and different machine learning models, and we've shown that the LSTM model is best for the studies. And this is the snapshot of CANI dashboard. When we predict we can show the predicted methane gas values. And conclusions, we know that we are over 5 years. We have to work on the Industry 4.0. And we have to work on the digital transformation of the any hardware industry, and this work is supported by those funding agency. And this is all from my side.
Thank you, Dr. Vishwas. This is a very nice presentation, and you have rightly pointed out how the IoT is important in the current era. Because as a mining engineer, when we try to get the data, we get this data in a discrete form. We are very generally from the underground, we acquire the data in a very less manner. So your research will be very helpful to gather the data and analyze it. And your presentation is very practical. The mine is the underground coal mines is really facing the problem of the fire damp explosion. So if your this research output will be helpful to mitigate the problem of the this fire dam exposure. Thank you, Dr. Vishwas. So our third eminent speaker, Mr. Darshandeep Bharadwaj, has joined. I welcome you, sir.
Thank you.
Let me briefly give his introduction. Mr. Darshandeep Bharadwaj passed out from IIST Shibpur, former B College Shibpur in the year of 2004. He got selected through campus interview in Hindalco Industries Limited. He worked in Hindalco Industries for about 6 years and contributed immensely in the development of mines and implementation of the state-of-the-art technology in day-to-day mining operation, and thereby increasing the overall mining efficiency in terms of output, machinery performance, etc. In the year 2010, he got selected through Union Public Service Commission for the post of Assistant Controller of Mines in the Indian Bureau of Mines, IBM. Indian Bureau of Mines performs the regulatory functions under the provision of Mines and Minerals Development and Regulation Act 1957 and enforcement of the rules framed thereunder, namely Mineral Conservation and Development Rule 2017 and Mineral Concession Rule 2016. IBM works as a national technical regulator for the mineral sector. After joining the IBM, he worked in regional officer at Dehradun, and subsequently he was posted in Delhi in Ministry of Mines, wherein he assisted Joint Secretary in the formulation of policy, regulation of mineral sector, and day-to-day technical matters. During his posting in IBM regional office in Gandhinagar, Gujarat, he worked as nodal officer for the mining surveillance system, a system to facilitate in detection of unauthorized or illegal mining by making use of space technology in the form of satellite images. He worked in Indian Bureau of Mines headquarters at Nagpur, wherein he was involved in the development of mining tenement system, which is aimed to make all the process of IBM in online mode. Recently, he has taken as in charge of newly regional officer at Vijayawada. This office has jurisdiction over entire Andhra Pradesh state. Sir, we are honored to have you with us, and it is very honor us to get the words from a regulatory person. So the screen is yours, sir. Please.
Thank you so much, Dr. Arkya Jyoti. I hope I am audible to you.
Yeah, yes, sir.
Okay. You have given a detailed introduction about me. Thank you so much for that. Actually, IBM discharges regulatory functions in terms of implementing various rules under the Act. So as is a regulatory function, we have developed one mining surveillance system, the one which you told about that I worked as a nodal officer for that mining surveillance system. It was developed in association with Bhaskaracharya Institute of Space Application Geoinformatics, which is based in Gandhinagar. So initially, when we developed the system, the things were in our mind, we should use space technology. Space technology in the form of satellite image to make a system which is robust, which cannot be tampered with, and that gives us the true pictures what is happening in the field. So I'll share with you that presentation today, and if time permits, I'll discuss very little about mining tenement system also, because I work in mining tenement system project also in Nagpur. So I am sharing my screen to you. Screen is visible to you?
Yes, sir.
Okay. So let's talk about what is mining surveillance system. It's the application of 2-3 components at one go. One is information technology and other is space technology. Space technology in the form of the satellite image that we are procuring from National Remote Sensing Center in Hyderabad. That is the only institute in India from where you get the satellite image of whatever type you require as per your project, as per your needs. So we make use of the latest satellite image, which is available in the country, and superimpose the mining leases on satellite image by digitizing the lease boundary from Khasra map or cadastral map. This Khasra map, cadastral map is nothing. It is a lease map. A lease map which is given to a lessee when he start the mining operations. He is given a particular lease area, and he is supposed to do any mining activities within that lease area. If he goes beyond the lease area, then he's indulging in unauthorized mining. So this mining surveillance system checks that unauthorized mining. So this was our objective in the beginning, that we wanted to find out illegal mining that is going in the country by using the satellite technology.
Sir,
And when we talk about this
excuse me, sir.
satellite image, it has got some
I think
particular
your slide
area.
is not changing, sir.
Slide is not changing.
I think so, sir.
Yeah.
Is it there?
Not changing.
Yeah, yeah.
Give me a-
So put it in slide mode, huh?
It is in slide mode, sir. Just a moment. Is it
पूरा
changing?
पूरा slide दिखाई नहीं दे रहा.
अच्छा ठीक है. I'll again switch to
Presentation mode में करो.
ठीक है.
थोड़ा सा full screen होगा, full screen.
हाँ full screen किया है सर.
अच्छा.
Make
पहले
it
वाला में जाओ, शुरू वाला में जाओ. Start with the first.
right side. There is a mode. There is different mode. You select the page. Not slideshow. You click on the slideshow. Then from beginning. Home, insert, design, animation, slideshow.
Just a moment.
Slideshow. Then design. Then animation. Then slideshow. Then slideshow. Slideshow.
Is it visible now?
No, you click on the slideshow.
No.
Then from beginning.
Okay.
Design, then animation. No. Design, then animation. Then slideshow. Home, design, animation, slideshow.
Just a moment, sir. Animation and slideshow.
Slideshow.
Yes.
Yeah.
Click on slideshow.
Yeah,
Then from beginning.
from beginning. Is it visible now?
But it is SMS.
Click on slideshow from beginning. Click on them.
That I clicked, sir.
I click
I believe you start from beginning again.
Okay, sir.
from beginning.
You go out from the share. You go out from the sharing.
Okay, okay, right, sir.
Now you share again.
Okay, sir.
Sometimes this is a problem of our digital system.
Yeah, yes, sir. From beginning, I'm selecting here, sir.
Click. Just click. Yes. Now it is.
Now it is coming, sir.
It will come.
This is not changing. You change next slide.
Yes.
Changing, sir.
No.
No.
Not changing, sir.
No.
Slide number 2.
Okay, I'll just take a help of one of my technical assistant. He will.
Yes. Take. I believe from current slide. Now it is.
मनी को बुलाओ मनी.
Now objective is seen. Your
Objective.
second slide is the objective, no?
Yeah.
That is objective, sir.
Second
But
slide.
it is not in this slide mode, sir, or this full screen.
But objective is visible.
So I can go with that.
Yes, you go.
Just a moment. Mani, this slide is not moving ahead. Like slideshow I'm going now. Yes, sir. Like this is in live mode. Sir, objective is visible to you now?
Objective
Yeah,
visible.
Visible.
Go
Okay.
for next slide also in front of him. When it is going
Methodology?
for next slide.
Methodology is visible or not, sir? Not changing.
Not changing.
No, not changing.
Just see money if we can. Stop sharing, start again.
Just
You
sharing
ask-
the entire screen.
You ask him the share entire screen from beginning.
Share the entire screen. Okay. Screens. This is some mail. This is presentation is there. This photo. This. Go to slideshow.
Yeah.
Yeah, अभी आया.
Yes.
Slide is
Now
changing.
it's clear. Very clear.
Now
Now
it's
it's clear.
Now it is very
Yeah,
clear.
yeah.
It's
Very
okay.
clear. Very clear.
Thanks,
It's
Mani.
okay.
Thanks.
It's okay.
So
Yeah.
sometimes this is a disadvantage of technology. We are
Yeah,
stuck
yeah.
on
It's
somewhere.
okay.
Okay, fine. Carry it on.
Yes. So this was our objective. I think I've discussed with this. When we go for the satellite image, we have to pay some cost for the satellite image. So we have to limit our area, that area which we want to see, that is area of our interest. So we are doing the surveillance of any mining lease area, and outside the lease area up to 500 meter of buffer zone that we call as a buffer zone. So any incident of unauthorized mining happening in that area, that will be reflected in our system as a trigger. And this system is being developed initially for the major minerals leases, not the minor mineral leases and not the coal mining leases, because IBM looks after the major minerals of the country. So this is how these 5 points are covered here in this presentation. Actually, first challenge for us was there was a need to plot the entire leases of the country. So we had to take the help of all the regional offices. Each office had to nominate 2 officers and get this leases superimposed on this satellite image. This task was undertaken in Gandhinagar, Bhaskaracharya Institute of Space Application Geoinformatics. So any lease area that we are plotting, that lease area will be monitored for the unauthorized mine if anything happening outside that area. So we had to procure the satellite image of any particular time period that we wanted to monitor. Cartosat 1 data was initially used. Nowadays we are having Cartosat 2E data also with us that is being used. But that time when we started the system, this was available with us. And if required, if you know that somewhere the illegal mining is happening regular basis, we need to tune the satellite to that particular area. That we can do through NRSC. We can request them that we want to monitor these particular area more frequently, so that illegal mining does not happen in that areas. So as we know that satellite image has got its own advantage. Eyes in the sky, that is one of the best part of the satellite image. We don't know at what time the satellite image will be passing in from our lease area. So all the lessees are alert in all the time that detection and deterrence from the illegal mining. So if it is detected, then there will be some penal action will be taken against that lessee, which will be a lesson for other people also not to indulge in this illegal mining. In this case, we have very less human interference. That means whatever is the image we are capturing, that image itself is telling whether it is a correct thing or not. And every time it is not possible for us to go to remote areas like mining areas are located on hilly terrains. So we cannot go at every time monitor it. So in that case, the satellite image is one of the best technology. Then we have integration of information from multiple sources like satellite image, cadastral plan, and other sources which are coming at one places. Then this is an effective tool for monitoring illegal mining. We can find out the locations, we can find out the extent and trends where it is happening, and we can generate various MIS report based on our requirement. So I'll just like to show you in next 4 to 5 slides very shortly. I'll try to take you up in this MSS, how it has been done. So this is a particularly a Khasra map, or we call it a cadastral map of any mining lease area that is given by the state government for any miner. We had to go for scanning of this map and georeferencing. Georeferencing is a big challenge for us, that we have to find out where that satellite image is falling on that lease area and how best we can georeference it. Then finally get the process of digitization of georeference village map. Now on my right side, you can see a satellite image of any particular lease area. On my left side, it is a cadastral plan. So we have to superimpose this cadastral plan on this satellite image so that we can find out its location. So for doing that, we need to have some permanent features on this map as well as in this satellite image. This is a road which is passing through this satellite image, and same road is being reflected here in this map also. So we have to find out at least 3 such permanent features which will be utilized for superimposing it. This is one of the case of Rajasthan, which I am showing to you. So when we superimpose this mining lease map or satellite image, we can see that this road is exactly matching with what was there in map and what was there in satellite image, plus some other road which are passing through it. We can find out accurately where that satellite image is having the figures. So once we do that process, we simply draw a line. That line will show where that mining lease is located, like this. This is 500. This is actually lease area of that particular mines, Malia Kheda lease area. And this color which you can see is a 500-meter buffer zone. So any activities which is within this area will be monitored. This is one of the case where we have just shown for the example purpose that this is a particular lease area. We can see some time back that there is no mining activity which is going in this area. But when we compare it after some gap of about a few years, then we can find out that there is a activities within lease area as well as outside lease area. So this within lease area is not a concern for us, but whatever is outside lease area, that is a matter of concern for us, and we will mark it as a trigger. That trigger is a potential area of illegal mining, and that has to be verified in the field by the state government officials. We cannot tell from the sitting in the lab that this is actually illegal mining. This could be some other lease which has been granted for minor minerals. That could be another case. There could be an excavation for the agriculture purpose also within this vicinity of this lease area. So to verify it in the field, we send those triggers to the respective state governments. So this is the process of generation of the triggers, which I just shared with you. These are being analyzed at BISAC, and they take out the triggers. And this is exactly a trigger which you can see. This is a lease area, this red color. And this purple color is showing as a 5-meter buffer zone. Within this there is one illegal mining which is being seen. This is reflected with this yellow color. These coordinates are marked in this map, and we send it to the respective state government for taking up the further field inspections. So for doing all this process, this is completely a paperless process. There are no pen and paper being used. Everything is done in digital format. And there is a particular mobile app which is developed by the IBM for the state government official. They will use it and find out the actual position in the field and submit a report to us. So this is how this mining surveillance system works in the country. It has been operating from year 2016 onwards, and every year we are finding some triggers that we are giving to state governments. Now I'll just take 2 minutes to explain you about mining tenement system also. This is also one of the flagship project of Indian Bureau of Mines, where we are making everything in the online mode. That is, it is promoting for doing the ease of doing business. And last year only we have been awarded the Atmanirbhar Award for this particular mining tenement system project. So I'll take you to our this website only directly and show you briefly what are these portals. It has number of modules. First module talks about the registration model. Every lessee, whenever he start mining operation, he has to be registered with IBM so that we can find out who are the registered owner. And the returns module, which talks about the returns submission every month, every lessee is supposed to submit the returns. And mining plan module, this is very important, a very exhaustive document. Earlier, people used to submit a mining plan in hard copy that used to run in 300, 400 pages. All the mining engineering things used to be captured in this mining plan in the offline mode. Now we have made the entire process in the online mode. So this document is submitted in the digital format to us. And this is being approved by IBM. Then drone data module. Every lessee is supposed to give us the drone image of the activities which has taken in the lease area at end of every year. So that system captures all the drone data images in this. Star rating module, which are the best performing mines, we are given star rating. They have to be submitted in the online portal. And final mine closure plan, at the end of mine closure, a person has to submit a final mine closure plan that is also captured in the online mode. And the new model is being launched for prospecting license. Anybody getting prospecting license, he has to submit his prospecting proposals into this. And these are our internal modules, which talks about the average sale price of every minerals and ML and directory. That is internal module. We make the mineral lease composite directory also. And these are the modules which are shortly coming up: notice, revision, inspection, mineral processing. So this was what I was supposed to share with you today about briefly about mining surveillance system as well as mining tenement system. In this brief presentation, I think I've shared with you these two things. So thank you so much for giving me this opportunity. And a special thanks to Professor N.C. Dey, who is our mentor all the time. Whenever we are in trouble, maybe we are in industry or in regulatory framework, we always consult sir, and he's always helping us in any of the matter that we are. Not from now, right from the college time, he's helping his students. He likes his students so much that any student will like to approach him for any kind of help that he will render to us. So thank you so much, sir, for giving this opportunity.
Thank you, Darshan, for your really illuminatory words and the speech. It's really helpful for all of us because I was also not knowing this. Very good, very good. Thank you.
Quite interesting.
Darshan.
Thanks, sir.
Yes.
Thanks.
All the papers, to me, it was really good. Arindam,
Yeah.
your paper also very nice to look at. Now again to Arkajyoti.
Okay, thank you, sir. So I would like to say thanks, great thanks to Darshandeep sir for knowing to let us know what are the initiative the IBM has taken to ease the doing of the mining. And before taking the question answer session, let me sum it up the today's whole session. We have three eminent speakers from the academia and the regulatory authority. The first speaker was the Professor Dey, who presented the smart mining and the human factors. He emphasizes the different occupational health problems, and he also told us how to design the workplace so that we can use the full efficiency of the workers. And also he's the pioneer in this field, and if we search the ergonomics, I think the first name will come in the India is the Professor Dey in this ergonomics field. So he has developed one index to know the whether any person is under the occupational health condition problem or not. And also he emphasizes that how we can increase the productivity or safety in the mining by implementing the ergonomic application in the industry. So thank you, sir, for enlightening us to know how the importance is the ergonomics, not only in the mining. It is a application of the every field we can apply the ergonomics. Thank you, sir. Our second presenter was Professor Vishwas. He presented the importance of the IoT to mitigate the risk of fire dam explosion. It is really the need of the hour to implement the IoT and the machine learning to acquire the data from the mines and to increase the safety and the productivity of the mining. He has developed one such type of the IoT device to detect the fire damp explosion, whether any mines under the risk of the fire damp explosion or not. So thank you, sir, for your great initiative, and I think your research will be helpful for the mining industry. And our last eminent speaker was Mr. Darshandeep Bharadwaj, who was the controller, deputy controller of from the IBM. He presented and he informed us that the use of the space technology on the mine surveillance system and what are the steps the IBM has taken, like the mining tenement system to know the whether any illegal mining is going on, or what is the position of this mine boundary condition, what are the lease condition. He has explained them very nicely, and I think it will be very helpful those who are working in the mining field. So thank you. Now the screen is open for taking the questions. So if anyone has the question, he can write in this question answer panel. Is there any question from this audience? Yeah, one attendee has a question to Dr. Vishwas that
I have one question.
yes. Dr. Vishwas, please.
Is reported. However, IoT sensor-based data is collection is done at deep inside mines and probably analysis to be done elsewhere. So capture data inside the mines increased reliability to the analysis. That LSTM is the machine learning model. Actually, that model is captured the data, but not for near about 8 hours duration. Okay, based on that 8 hours data, captured data from underground mines, that LSTM model nurturing the data that predict the how the there is a accidental how there is a methane gas monitoring, how the methane gas concentration that they are reported accordingly, and that data from underground mines to that LSTM model that is go to the cloud, and for that purpose we have used the Amazon AWS cloud. Data is going to the Amazon AWS cloud, and from that Amazon AWS cloud, that LSTM model is deployed within that Amazon AWS cloud. And I think in that part, I am so fast, but there is a diagram, and in that diagram that was cleared. Can I show that diagram?
Yes.
Please show. Then it will be clear. If possible, please show.
Slide is not changing. Please see this diagram. Please see this diagram. Here, that's LSTM model is deployed within the AWS cloud. And from this AWS cloud, it is going to the internet, and this is the both way directions. And from that internet, we can get the router And also,
Dr. Biswas, I think this attendee has questioned you. If you see the underground mines, it is a very zigzag pattern. The several galleries is there. So I think this data transfer is only possible for if the line of transmission is very straight.
yes, yes.
So his question is how you can capture the data from the underground if there is a very zigzag roadways.
Okay.
One question is this, and
We have
another
to-
question is
we
this:
have to deploy
how
the
and he
wireless
has
sensor
also
network. We have-
asked another question, that how you have incorporate the dynamic nature of the mines in your to capture the data.
Very important question.
For
Very
that
important question.
purpose, we use that WSN network. We have deployed different node in different location, and we have to study that location. This is our model still in the prototype, but we have to study the location thoroughly, in which location we deploy it, and we have to use the wireless sensor networks node in different locations to capturing that whole area.
No, Arindam, whether during capturing the data from, as Dr. Das was also telling, as it has got the branches, it is not the straight line. Okay,
Yes.
the branches. So whether during collection or collating the data or information, do you have encountered any sort of trouble?
Still now that model is prototype, that is deployed, that is tested in our laboratory level.
Oh, acha, it is not yet developed
But,
rightly.
but in our concept is that we have to study that locations very carefully. And we have to use the wireless sensor network in every node, and we have to check that every node, that those nodes are sense whole locations. We have to study the location. This is the location based. We have to study the locations and gets the problem. Accordingly, we have to sort out the problem based on the
Arindam, if we can just you see the queries, if instead of 1 or 2 sensor, if we increase the number of sensor, if of course if the cost allows permits, then because one sensor will give the supply the data to this, and this will supply the data to somewhere else, and finally the data will be captured in the manager's room or office.
We
So
must
is it
deploy
feasible?
different sensor, sir. We must deploy different sensor, and we have to study the locations, and we have to ensure those sensor covered entire location.
Hmm.
This is the location.
I think there should be a network of the sensor.
Yes. That is there, and our technology is wireless sensor network.
Okay.
Acha, another thing, Arindam, possibly one of guys have asked also, whether the underground that your hostile environment of the high humidity of 95% or the temperature is more than 40 degrees centigrade or the huge dusty atmosphere would encounter some trouble. Have you got into it or yet to be seen?
That's why we are using the SNO2 based sensor, and those sensors is the humidity, temperature can't damage those sensors. But in case of any sensor, we have, this is in the prototype model, we have to suppose we are getting some trouble when in case of deployment of the sensor, then we have to work and we have to done our research accordingly.
Lot of areas to be covered. No?
Yes.
Achha, next question you see, or
yeah, Dr. Biswas, there is a one question from Shanti Prasad Maiti. He said that it is his opinion that inside mine, WSN is quite unreliable and will affect the performance accuracy. Please elaborate this aspect.
Now the research on the WSN, WSN is going on. We have improved. We have deployed the different this model. This publication is there. A differential layer evaluation based improved clustering algorithm, and for IoT heterogeneous wireless sensor network. So this heterogeneous terms is introduced to WSN networks to encounter those problems. And now the WSN networks in underground is reliable after introducing this IoT-based heterogeneous wireless sensor network.
Okay. Then another question from this Shanti Prasad Maiti is that after getting the data, whether the computation will be very expensive because there is a huge number of data is coming. So how you will compute this data?
That's why we have used the LSTM model. LSTM model stores only data during this 8 hours directions, and this is the long short-term memory base.
Okay. So my question, this is my question is that if after getting this data, will you compute this machine learning process in cloud computing or in your own server?
Cloud. We have used the AWS cloud for that. And AWS cloud stored the data for 8 hours only.
Okay.
This is the LSTM based model, short-term memory model.
Okay.
But he has got another question also. You see how data from mines reach to the analysis end.
Yes.
That data sensor sends the data that then it will be sent by wireless sensor networks to the internet through the routers. This connect to the IoT devices with internet.
He has got little more questions. Please read, Orko.
Yeah.
ML-DL method.
I've already asked this question, sir. Computationally expensive, whether it is not.
And we have used the AWS cloud for that.
Okay. And another question, last question is this: how this would be effective for real time in miners?
Yes, this is effective from real time miners because we are getting the real time data. And this data is sent to the AWS cloud, and LSTM model is deployed within the AWS cloud. And this is the machine learning based model, LSTM model, and then that model is using through AWS cloud.
But inside the mine, WSN is quite unreliable. Do you agree with?
Yes, sir. From making this reliable, we have worked on the WSN networks, and we have introduced the IoT-based heterogeneous WSN network that is published in Journal of Communication Systems, shown here. That is the title is that a differential evaluation-based improved clustering algorithm for IoT-based heterogeneous wireless sensor network. We have introduced the heterogeneous wireless sensor network.
Okay.
That also work in underground mines. For in details about heterogeneous wireless sensor network, we can go through these publications.
Perhaps the person from Institute of Engineers has raised his hand.
Who?
The Institute of Engineers.
It's okay. I think all questions are being
answered,
taken care.
And also there is a one question for Dr. Biswas, but this work on 8 hours data, this is far different from the present data, which is more relevant and useful to the miners.
For any kind of prediction, we have to we need the data. Data is the main thing. If we predict the data, 8 hour data, we can predict the nature of the data. Based on that nature of the data, we can predict the environmental conditions of underground.
Okay. Is there any question? I think all the questions has been answered. So I would like to request.
Outside this, I have given my my phone number and my email ID available in our website also. SP Maiti, the questions from the SP Maiti, if he is not satisfied with those answers, he can connect me to the email available in our website.
Yes, exactly.
Okay.
So I may request the person from Institute of Engineers to give a vote of thanks.
Yeah, I think we are almost at the end of this session. But as we know, the knowledge never stops flowing. It keeps on flowing, even though we are at the end of the session. But this can become a new milestone for the new engineers or the new scientists who are coming ahead to do further research work. But however, as any physical event, as we start, we need to end it. So I will take this privilege to thank Professor Nitai Chandra De, HOD Mining, IIEST Shibpur, to take immense effort to organize this event, to organize this webinar on the topic smart mining technology under man and machine interface, which is a very contemporary topic. I will also like to thank Prafulla Chandra Tiwari, Engineer Prafulla Chandra Tiwari, Chairman Mining Engineering Division Board, Institution of Engineers, to support this event, to organize this event. I will also like to thank Dr. Arkojyoti Das for moderating this webinar very carefully, maintaining the timing, introducing the moderators, introducing the panelists, also summing up all the presentations given by the 3 panelists. I will also thank Professor Nitai Chandra De, Dr. Arindam Biswas, and Mr. Darshandeep Bharadwaj, the 3 panelists who have shared their knowledge, their authority and expertise in their own field. They have given the immense knowledge to us and enlightened us with their work, with the practical experience, which can become a very learning to the newcomers, to all the attendees who are listening this webinar. At the last, I will thank to all the attendees who have been a patient listener to this webinar. Without them, this webinar would not have been a successful one. So at the last, I will thank all of you for completing this webinar successfully, and good evening to all of you. I think with the permission of the chair, I will like to end this webinar.
Tiwari sir,
Sir,
we are waiting for your permission to close it.
perfect, sir. Perfect.
Okay, sir. Thank you, sir. Thank you,
Yes.
everyone.
Thank you very
Thank
much.
you, sir.
Thank
Thank
you,
you,
sir.
sir.
Thank you, everybody,
Okay.
for
Thank
your
you all.
cooperation.
Certainly, the
Thank you.
first webinar I have seen, it is completed within the time.
Yes,
Yeah,
yes.
almost. Yeah.
Exactly 7 p.m.
That's why I thank
Thank you, sir.
moderator again and again for doing it.
If any question comes, if there is still
Yes, yes.
participants are listening, if anybody is interested to put up more questions in future or in days to come, please feel free to contact us or even Institute of Engineers Headquarters, Kolkata. Then
Yes.
every question should be answered. Thank
Yes,
you
sir.
very much.
Thank you, sir.
Thank you.
Okay, sir. Thank you. Sir.